Hello and welcome to our fourth vlog on how to build effective in vitro assays for early drug discovery. In our previous vlogs, we have discussed the key principles and practicalities of bioassay design.
Here we look at how you can carry out bioassay validation to confirm that your bioassay is fit for purpose. Setting up sufficient control wells. Controls differ depending on the bioassay you're running, but you should always include both positive and negative controls in equal numbers to ensure that the statistical analysis is not skewed in one direction or another. Using an appropriate pharmacological reference or standard compound. To enhance your bioassay's robustness, use a pharmacological tool or reference compound. This will allow you to measure the reproducibility of your bioassay as well as inter-assay variation independently of the controls. Applying key statistical parameters. Statistics are an important tool to determine whether the compounds you test have a significant effect when compared to the controls. Several parameters need to be considered. Signal to background or signal to noise ratio. Signal to background is measured as a ratio of the mean of the high controls to the mean of the low controls. Signal to noise ratio is calculated as the maximum mean signal to the minimum mean signal divided by the standard deviation of the assay. Assay variability. This is measured using the standard deviation of the control wells to calculate the coefficient of variation. Z prime, Z factor, and Z score. Each method provides a statistically relevant value that determines the reproducibility of your assay controls. This takes into consideration the standard deviation of both the positive and negative controls, along with the assay window and the activity of any compound outside of a null effect across all samples on the plate. In the search for that crucial active or hit compound or biologic that interacts with your target biology, you need to be sure that what you think is a hit is actually a hit. Otherwise, you risk basing your decisions about whether to progress your compounds on inaccurate data.
So how do you define a hit? Most compounds you will screen will have activity centered around zero, that is, the null effect. An active compound will have activity that is distinct from the background noise of the assay. A hit is a compound that consistently shows the same activity in a statistically significant way.
To validate your results, screen compounds with known activities, ideally with a range of potencies, along with controlled samples on the same day and different days. This will increase the confidence you have in your assay to detect active compounds in a consistent manner.
Despite best efforts, you may find that your bioassay development is hindered by challenges that are difficult to resolve. These issues are more common than you might think.
So, in our next vlog, we will answer some of the frequently asked questions in bioassay development. Follow the link in the description to download our free ebook for more insights. Contact us to learn more about our capabilities and services, and subscribe to our YouTube channel for more such videos.